For the measurement of the static pressure in the fluid, there are various methods are available, out of which there are few which we will be discussing today. So first is your barometer. So this is well known to all. Okay, for the measurement of the atmospheric pressure, we simply use the barometer. Second, we will discuss the manometer. Third, we will discuss the manometer rule also. What is the manometer rule? So first of all, here we will understand how this work, what is the principle behind it, and here we will understand that by a simplifying rule, you can easily measure the pressure. And third one is your differential manometer. Differential manometer. Now, using all these three, we can always measure the pressure in the fluid, and similarly some modification into the these differential manometers are also available, which we will discuss in this one. And there is one very important thing which is being used in the modern era, that is your Bourdon gauge. Okay, so and the last which is used for the especially in the case of the research areas, where you have to precisely measure the how the pressure is varying at the various location, either in fluid or any other medium. These are the pressure transducers. Pressure transducers. First topic of this one, barometer. So let's move to the today's first discussion, that is barometer. On the right side, a simple barometer has been shown to you. So this kind of barometers are especially used for the measurement of the atmospheric pressure. Now this was devised in the 17th of century, and the person who was involved for doing all this research and evolving this kind of method to measure the barometric pressure was the E. Torricelli. So in this setup of barometer, there is a open-ended glass that is completely filled up with the mercury, that is the fluid used for the setup of this kind of barometer. So this open-ended tube is completely filled up with the mercury and then inserted upside down, such that a vacuum is being created over here into a disc which is completely filled up with the mercury. So this material which is available here is, this is mercury and this is also mercury. So what exactly happens over there, here the vacuum is being created. However, during the procedure, once you are making it ups down, there may be air bubble may go. So that's why we have to be very careful while we are making this open-ended glass tube upside down. So due to this vacuum, a very small vapor pressure is being created. There is one benefit which is involved by using the mercury for this kind of measurement device, which is used for the measurement of the atmospheric pressure, is that the vapor pressure which is being generated here during the glass tube is made upside down will be very low. So that's how this is completely equivalent to a vacuum pressure over. So Hg produces very low vapor pressure. That is why as much as low vapor pressure will be there, this situation will be very close to the vacuum, and that's how we can accurately measure the atmospheric pressure. Okay, now let's understand how this works. So let's understand the principle behind it. So here on the surface of this liquid, the atmospheric pressure is working over there, So what exactly is the scenario is that pressure at the point C, that is equivalent to P atmospheric. Now, uh, along this horizontal line, pressure throughout along this horizontal line, pressure will be the same. So whatever the pressure at point C, that is also equal to pressure at point B. Now, if we figure out what is the pressure at B, there are two ways. One way is figuring out that what is the horizontal, and in other way around we can make a calculation that how much height of the mercury column is above this one, and that's how we can calculate the pressure at B. So pressure at B can also be written as pressure at A, whatever pressure at A, plus gamma of mercury, that we can write Hg is the symbol, and then height above the point B is H. Now we know that almost vacuum is here at this location of A, so Pa is your 0. Now we can write that Pb is equal to gamma Hg multiplied by H is the pressure. Now we are knowing that this Pb can be written as P atm. You can see this is all the way coming from this way, equation this and this, because Pc is equal to Pb. So P atm or atmospheric pressure can directly be measure the height of the mercury column, which we are able to see in the barometer. Now normally we measure the height of the mercury in the column in millimeter. So if height is measured in the millimeter, then accuracy will be more. Standard atmospheric pressure is equal to 101.3 kPa, that is kilopascal. Now in order to achieve this pressure, the height of column that is required for the mercury, that is exactly 760 mm. This height of column is required for creating an equivalent pressure to the atmospheric pressure. Now, so let's talk about what is the density of this mercury is. So mercury density is, exact value is 133,550 Newton per meter cube. That is the density of the, not density, this should be called as a specific weight. So this is your specific weight of the mercury. Now there is one additional point that one should take care of, that one, that temperature at which all the measurements are being done is very crucial. Why it is so? Because vapor pressure of the Hg is always vary with the temperature at which the measurement is done. So in order to get the exact pressure, we must know the vapor pressure at that temperature of the Hg, so that whatever pressure we are getting, that we can deduct from the actual value, and that's how you can get the exact value of the P atmospheric. So let's start with the manometer. So manometer is a device where a transparent tube is used to determine the gauge pressure in the liquid. So what exactly we measure is gauge pressure, not the actual absolute pressure. Okay, so we are measuring the pressure at any location with reference to the atmospheric pressure, that is your gauge pressure. Now, the simplest type of the manometer, which is called as piezometer, has been shown in here, is this is a piezometer. Using this simple device, anybody can measure the gauge pressure at any location. So, using this piezometer, any any pressure at any point can be measured by just inserting a tube which is open at the both end. Now, once you insert this tube, this tube will be a rise of height h, and this will give you the pressure head at this particular location. So, in order to get the pressure at point A, we can use the equation that PA is equal to gamma, which is the specific weight of the liquid which is filled inside this one, gamma, and this height is D and then H. So height of height of the fluid column above this point is D plus H. So we can exactly find out the what is the pressure at the point A just by noting down the what is the rise we have witnessed in the inserted test tube. Now there are two additional points we have to note down. Point 1 is that for a very high pressure inside this one, this manometer doesn't works well, because in order to measure a very high pressure, you need a very long tube in order to be inserted over. So in case of very high gauge pressure this should not be used. Second thing, also this is not effective for measuring this is not effective for measuring for the negative gauge pressures. Measuring the negative gauge pressures. Now why it is so? Because when once you insert this tube in the vessel, what scenario where maybe there will be a leakage of air may also be at this location. So due to the negative pressure, that is very much possible. That's why in both these two situations we should not use the manometer. So what else we can use for the other pressure? Let's discuss further. Now when we have to measure moderately very high pressure, very high gauge pressure or negative gauge pressure, in both situations we can use a U-tube manometer. Why there are so many devices are available, you have to understand what are the limitations for each device, and because of these limitations a new device was introduced in order to assess the pressure measurement in any particular situation. This manometer, there is a vessel where a liquid having the density of gamma is filled up and a U-shaped tube is attached herewith. Now in this U-shaped tube, in order to measure a very high gauge pressure, we used to fill up another liquid having a higher density, which is gamma dash. So usually this gamma dash is which is filled up in this tube is mercury. And if you can see that point E is, this is open to the atmospheric pressure. So pressure at E will be the atmospheric, and using this device we can measure the pressure at point A. So before proceeding to solve this problem, how the pressure will be measured, there are some observation you must note it down, that pressure at E is atmospheric pressure. Now pressure at E is atmospheric pressure. Pressure at E is PATM. Second thing which we can note is that pressure at A and pressure at B both are same. Why it is happening? Because they are on the same level, and also same liquid is there. Now another point is that point C, pressure at point C and pressure at point D both will be the same, because this is the same liquid and also in the same level. So using the same principle I discussed, we can write that PC is equal to PD. Once you are able to figuring out all these instances, because this is also same level, once you are able to find out all these things, all these observation, it is very easy to calculate the pressure at any location. Now what we can write is over here is that let's talk about the point pressure at point C. So we can write that pressure at C is equal to pressure at A plus gamma HBC. So gamma is the specific weight of this one, and the difference at these location is HBC. Now, so what exactly is PC is equal to PB plus this. So PB is equal to PA. So we can straightforward write this thing. Now similarly, we can write the pressure at C. Pressure at C, that is also pressure at D, we noted down here, is equal to gamma dash multiplied by HDE. Now as we are measuring the gauge pressure, so here is the P atmospheric pressure, and if we talk about this one, so this is height is HDE and multiplied by the density of the fluid which is filled up in this tube. Now let's take this equation as 1, this equation as 2. So if we compare this equation, we can just replace the value of PC in this equation. So this equation will look like, by just replacing the value of PC is equal to gamma dash HDE is equal to PA plus gamma HBC. Now so the pressure at A will be gamma dash HDE minus gamma HBC. So the final equation we are figuring out is this one. Now let's take another point. Suppose in this liquid, in this vessel, the liquid which is filled up over here is gas, and the gas will be having a very low specific weight. So assuming that for instance, that assuming that the liquid which is filled inside the container is gas. So gas के केस में specific weight of gas will be very low. So we can assume that this is almost 0. So the expression we wrote here for the PA can be rewritten as PA is equal to gamma dash multiplied by HDE. So if you are measuring the pressure in a container which is filled up with the air, you can directly use this equation without having any substantial error. Now there are two more points are there for the discussion. So in order to reduce the error when using a manometer, it is best used to a fluid having a low density, low specific gravity. Especially you can use the water. So what happens once you are using the second liquid, which is filled up over here as a water, there will be benefit that it has a low specific gravity, so height of rise will be high. So in such cases, the measurement you are doing for the measurement of for the height of rise will be will be more precise. So that's how when height of rise is much more, then precise measurement will be definitely helping you to figure out the exact pressure, because uh, when the height will be higher in the manometer, so your pressure head will be more sensitive toward the pressure differences also. So first point is this one, that you should use the low specific gravity liquid, so that height will be more precisely can be measured. Second important point is also there, that if you want to go for a very much precise, then temperature is also affecting the specific gravity of the liquid which is filled inside this one. So if you can consider the contribution from the temperature, in the specific weight, then you can go for more precise calculation, more precise measurement of the pressure. So we can write that gamma is function of temperature. Okay, so if you are taking example that 20 degrees Celsius and 50 degrees Celsius, two different liquids will be having two different specific weights, and once specific weights are different, the rise will also be different.